So we've talked about graphing lines. Now we're going to talk about graphing quadratics. So before we actually graph quadratics, I want to talk to you about what the graphs look like and what they do, and it'll help us as we start graphing them. Okay? Does anybody know what it looks like when you graph a quadratic? Anybody? This or this? Do you know what that's called? It's the graph of a quadratic. Do you know what it's called, though? Another name for it?
What's the first letter?
A P?
Parabolas.
Parabolas. You're absolutely right. These are parabolas. So parabolas have some special qualities I want to talk to you about for just a minute. The first thing that's really special about parabolas is that, and maybe you can notice this, if you look at them, think geometrically what's special about them. From one side to the other. Starts with an S. So, graphing quadratics in standard form. They're symmetric, absolutely. So if they're symmetric, that means they have a line of what? Come on, y'all can get this. Symmetry. If they're symmetric, they have a line of symmetry. The line of symmetry goes right down the middle. And we call this an axis of symmetry when we're talking about parabolas. Yeah. If you can find one that writes over there, I might have one. I don't think that blue one works very well. All right. Symmetry. So through this axis of symmetry, it crosses the parabola at one point, and that point is very, 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 very special. Does anybody know what that's called? You might not know this one. Bless you. Point. Vertex. Okay. It's the point where the axis of symmetry crosses the parabola. Now, a couple of things happen here. For one, if that parabola is happy and opening up, the vertex is the lowest the parabola ever goes, all right? So here, it's a minimum. But if I look at it and it's opening down, this vertex that sits at the top like that is the highest, so it's a maximum, okay? So how do we know that an equation is a quadratic? When that equation has an x squared in it, the x squared lets us know we're talking about a quadratic, so we're talking about a parabola, okay? So we're going to learn 3 different ways to graph that can be written in 3 different forms. The first one we're doing today is called standard form. And this is what standard foam. It's ax squared plus bx plus c. Okay? The a, the b, and the c are coefficients. They're the numbers in front of the variable. So if they're missing, then they're 0. And I'm going to show you a couple examples. So let me show you a couple in standard form, and you tell me what A and B and C are. 2x squared minus 3x plus 1. What is A?
2x squared.
Don't keep the x squared, just the number in front, though. 2. Okay, and that was one of the things, I'm glad you said that, because everybody wants to pull the variable with it, and it can't go with it. How about B? -3. And how about C? 1. Is anybody confused on how to find those? What if I change you?
No, I'm not confused.
Okay.
Could they be in another order and we'd have to move them?
Yes, because standard form always does the squared, the x, and then the constant. So you just move them around. Okay? But that's a great question, because if I wrote it this way, Okay, your A is still the one that's hooked to the x squared. A is always, yeah, so this would be x squared plus 5x minus 3. So what is your A? It'd be 1 in this case. Whenever I say missing, I'm talking about the whole piece missing. I'll show you one like that. It'd be 1 because remember you can always throw 1 in front, right, as a coefficient. What about B? 5. What about C? That was a great question, though. How about this one? What is A? 2. What is B?
0.
What is C?
0.
Good job. Easy? Yes, no, maybe so. Everybody okay? Y'all got to speak if you lost or if you get behind. All right. Graph. I want to show you one more thing about these standard form quadratics. The first thing I want you to look at is the A that sits in front. The A tells us two things, okay? If A is positive, it tells us that we're going to have a parabola that opens up. Remember those first two I showed you that one opened up and one opened down? If it's positive, it opens up. So what do you think that means if it's negative? It opens down. You're absolutely right. Negative opens down. So it's going to be like this. Does that confuse anybody? The other thing that A does, and this gets a little bit more confusing. We say if A is 1, that the width of the graph is an average width. Average. And what I mean by that is parabolas come in all shapes and sizes. Some of them may be skinny, and some of them may be wide. They're still parabolas, okay? So we say if it's 1, it's an average width. The bigger that A gets, though, if it gets to be 2, 3, 5, 10, then it shrinks the graph in. The graph gets skinnier. So you would think it'd be the opposite, right? The bigger number in front, the bigger the graph, but it's not. It's the bigger the number, the skinnier the graph. So then the smaller A gets, and I'm not talking about smaller positive or negative, because that has to do with up and down. I'm talking about smaller, like closer to 1, okay, or below 1, but doesn't go negative. So fractions like a half, a third, a fourth. What do you think the graph does? Bigger, that's right. That makes sense to everybody so far? We're going to do several examples with this.
Yeah, because we're skinny.
One more thing about this equation, and that's this C that sits on the end. Can anybody guess what that C might be? Think about mx plus b form and what that b does on the end. Y-intercept. It's same thing here, because remember for a y-intercept we put 0 in for x, and that would cancel those two out. So C here is my y-intercept, where it crosses the y-axis. A couple examples. And if you'll just write these down, then we'll talk about them.
Are we graphing?
Yeah, we're going to graph them in just a second. First thing I want us to do is identify A, B, and C. So look at the first one. What is A? 1/2. What is B? 3. What is C? Does this graph open up or open down? Why? It's positive, so it definitely opens up. If you had to classify it as skinny, wide, or average, which would you do?
Wide. Average.
I hear both. Oh, I heard everything. What are we looking at to determine? A. One is average.
So below maybe wide.
Below makes it wider. So would you classify it as skinny, wide, or average? Wide. Remember, it's kind of the opposite of what you think. The bigger the number is, the skinnier the graph gets. The smaller the number, the wider it gets.
What number makes it wide?
The 1/2. We're looking just at A. A tells us skinny, wide, up, down. If this is less than 1, it's wide. If it's bigger than 1, it's skinny. What's the y-intercept? -5. How about the second one? What's A? -5. What's B? What's C? Up or down? Down this time, because that A is negative. Don't look at the negative when you answer this question. Only look. Are you confused, Bryce? Okay. Am I going too fast? Okay. Don't look at the negative. Just look at the 5. Is it skinny, wide, or average?
Skinny.
Skinny. Because 5 is bigger than 1, right? What about the y-intercept? 0. Good job.
I thought you said if it was below 1, it was...
But don't look at the negative. Okay? Don't look at the negative because that's up or down. Just look at the number without the negative. All right, how about the last one? What's A? 3/2. What's B? Good job. I was trying to trip you up. What's C? 2. Up or down? Up. Skinny, wide, or average? Sure?
No, down. Skinny.
Why?
Because it's above.
3/2 is 1.5, so that's bigger than 1. So I'm skinny. How about y-intercept? 2. Anybody confused so far? Okay, y'all ready to graph? So the first thing we're going to do is we're going to identify A, B, and C. Okay, because that's going to help us as we go to plug and chug in this graph. So here, what is A? 1. What is B?
-2.
And what is C?
-1.
Is anybody confused? We all okay? This is not part of the graphing, but part of making sure we graphed it correctly. Will this one open up or down? Up. Skinny, wide, or average? Average. Y-intercept? -1. Okay? All right. First step we're going to do, or the next step we're going to do, is we're going to find the axis of symmetry. Okay? Because it's a vertical line, it's going to be x equals. Remember on the test yesterday we had the graph the line x equals something and y equals something. X equals is a vertical line, so this is going to be x equals. So we're going to do x equals, and here's the only part, it's a little formula you have to remember. Opposite b over 2a. Okay? Now that's a negative sign in front of that b, but I say opposite because if b starts out being negative, it's going to change it to positive, okay? So it's easier to think about it as opposite b instead of negative b. Am I in your way? Can you see? You sure? Okay, because I'm just like leaning all over. Okay. All right, so look at the example on the right. X equals. Opposite b is what? 2. Positive 2. over 2 times 1. So I got 2 over 2, which is 1. We all agree? Okay? That's my axis of symmetry. So if I go ahead and go to my graph, that means at 1 is my axis of symmetry. Now what happens on the axis of symmetry? What special point is on the axis of symmetry? The vertex, okay? All right. So the next thing I'm going to do is I'm going to find out where on that axis of symmetry that vertex is. So to do that, I'm going to plug x, and I'm talking about this x right here, in the equation to find the y part of my vertex. Okay, because I've got the x, I know the line it's on, I just need to know how far to go up or down to put the point. So to do that, I'm going to plug back in the equation. So what equation am I talking about? The very first one that I started with. Okay, so y equals, and this is just like where we were plugging in values for x, and you did that on your test too. Same thing, plug it in for every x. So plug a 1 in every time you see an x in this equation. So 1 squared minus 2, it's not x, it's 1 minus 1. Do your exponents first. 1 squared is 1, minus 2 minus 1. What does that give you? Negative 2. So that means on that dotted line I drew, I'm going down 2. Or essentially this vertex is 1, negative 2. So down 1, 2. Make sure you put a V there so that you know, hey, that's my vertex. Otherwise, you'll start getting your points mixed up. I'm going to give y'all. So I've got a couple options. Say again? All right, well, the vertex is the maximum or minimum. But what I want is I want an easy point to graph. Now, I can look at that equation right now and I can pick out an easy point. Do you see what easy point I might be talking about?
1.
Why 1? Well, close. Negative 1. But why? What is negative 1?
C.
Which is the y-intercept. That's easy, right? And I can use that in this case. So I can use the y. I'm going to put y-intercept if you can. Now, it could be that my vertex is my y-intercept, in which case I couldn't use it, okay? So I'd have to pick an x. When you pick an x, you go to your vertex and you add 1, okay? So you stay right beside your vertex. So in this case, if my vertex is 1, I could use 2. Oh, I'm putting it on the wrong side. And I'm doing this both ways so that if you encounter one, you can still use this little chart. All right, so I could use for my easy point 0, negative 1, that's my y-intercept. Or I could use x equals 1. If I have an x, though, how am I going to find the y that goes with it? Plug it in. Always plugging x's back into that equation. I know this looks like a lot. Some of y'all are like, is she ever going to stop? There's one more step after this, but it's easy. Huh? You're confused. Okay. I'm doing this 2 different ways in this chart, so you'll have it in your notes. If I were doing this problem, I would use this as my easy point, and I'd be done with it. But just in case you get to a problem and you can't use that, because if the vertex sits right here and my graph is going like this, well, then I can't use this as an easy point because I've already used it as the vertex. So I'd have to pick another one. So I wanted you to kind of see what you would do, okay? Or sometimes the y-intercept might be huge. Maybe the y-intercept is 50. Well, you don't want to graph 50, so you'd pick an x that's close to the vertex. All right, so I'm going to plug it in. 1 squared, 2, y'all, 2. Y'all aren't stopping me. 2 squared minus 2 times 2 minus 1. Because I added 1 to the vertex, moved over 1. 4 minus 1 gives me what? -1. Say that again. All right, so I did the opposite b over 2a in step 2. And then in step 3, I plugged that in. Okay? Now understand, what's written in blue, you're going to do one of the two. You're either going to do the 0, -1, or you're going to pick the easy point close to it. Okay? I just did both here so you'd have an example of both. All right, so I'm going to go and plot that 0, -1. Right here. Yes? You all with me? All right. Last thing I do, because this graph is symmetric and I've got a line of symmetry, the only thing I have left to do, I call this step reflect, because I'm reflecting over the axis of symmetry, and connect. So here, that's right. See the line of symmetry? Do we all remember how to reflect a point over a line? If that was a mirror sitting on the graph, where would it end up on the other side? Over 1. And then I can connect it into my parabola. Tell me what you think. It's a lot the first time you see it, I think.
Well, we got to do all that every time we work one,
Yeah. It's not going to be that long. I'm fixing to do one without the steps, and we work through it, and you'll see it's not as long as what it seems like. No, it's not. This is the hardest form to graph in. It's got the most steps. All right, so let's do this one together. Let's do y equals 1/2 x squared plus 2x. What? Huh? Say again? Yep. We're going to do it together. We're going to do several together, CC. All right, so step 1 was find A, B, and C. What's A? 1/2. What's B?
2.
How about C? 0. Should it open up or down? Up, because it's positive. Should it be skinny, wide, or average? Wide, because it's a half. Good job. Okay? What's the y-intercept? 0. All right, so we're ready to get started. So let's work on the vertex first. I got that little formula that I have to remember. First is the axis of symmetry. Opposite b over 2a. So if you wrote a, b, and c out, just plug in. What's the opposite of b? -2 over 2 times 1/2. Well, it's 2 over 2, which is 1. So, right, so I got -2 over 1, which is -2. Everybody with me on that? Just plugged into that little formula. No, where'd I lose you? All right, so I took my A, my B, and my C up here. Opposite B over 2 times A. A is a half. So 2 times a half is 1. Half of 2 is 1. And then the -2 up top. Okay, so, excuse me, that's my axis of symmetry. I need to know where to go on the axis of symmetry, so what do I do?
And we supposed to put it on the graph.
Yeah, this is the example 2 on the bottom.
Yeah.
It didn't have axes on it. Draw your axis on there, yeah.
You mark it with a vertex.
How do I find out where on this dashed line my vertex is? What do I do? You plug it back in, okay? And you can do this on your calculator. 1/2 times -2 squared plus 2 times -2. Do the exponent first, so you'd have 1/2 of 4 plus -4. What's 1/2 of 4? 2. And 2 plus -4 is -2. So that means, you okay? Down 2. Mark it with a V so you know that it's the vertex. So it's -2, -2. Yep. Anybody confused? That's the hardest part. Now I need an easy point. The question is, can I use my y-intercept as my easy point? Sure. Y-intercept is what? 0, right? That's the C on the end. There's not already a point at 0, and it's easy to graph, so use it. Now what? Reflect. Are you confused?
No, I'm just going wrong with the drag.
Okay. 1, 2. 1, 2. Now connect the dots.
Why did we put a point on coordinate again?
On 0, because here the y-intercept was 0, because that's your C. So that was easy to use for the easy point. I want to do one with you, though, that you can't use the y-intercept. Was that easier than when we initially went over it? Didn't take as long?
No.
Okay. Let's do what?
Why you put the other line over?
Which one? Use it, this point here?
Nah,
This one?
yeah.
I reflected it, so this dashed line is my line of reflection. Wherever the point is, you reflect it over it.
And you went 2 more over.
2 more of it, right. Count to the line of symmetry and then count that many more. So 1, 2, so then I count 1, 2. Let's do one like this. What's A? What's B? C. Up or down? Down. Skinny or wide? Skinny. Everybody okay? Okay. I'm sorry. Say that one more time. Yes, yes, because the opposite of 0 is still 0. All right, so this one's a little bit different. I'm missing the B and the C, but that's okay. First thing I'm going to do is that axis of symmetry, which is part of my vertex. Opposite B over 2A. 0 over 2 times -4. And it really doesn't matter what's in the bottom, because 0 is in top, and it's going to give me 0. Does that make sense? So that's my axis of symmetry. That's my dashed line. 0. Now I need an easy, oh no, just kidding. Now I gotta find where on the dotted line my vertex is, right? How do I find that? Because you need an X and a Y for the vertex. You gotta plug it back in every time. Every time you need another part, you're plugging back in. Does that make sense? You're looking at me like it doesn't. -4 times 0 squared, which is 0. So what's my vertex? 0, 0. Put a V. Now here's where it's different. I need an easy point. So the first thing I always look at is my y-intercept. What's my y-intercept? 0. Can I use it?
No.
Nope, the vertex is already there. Okay?
Now what's your vertex?
So add 1 to the vertex. That's exactly right. So for my, if you can't use the y-intercept, you just want to move over 1 from the vertex. So I'm going to let x be 1. Okay? If the vertex was at 10, then what would you be using for an easy point? If it was at 10, what would you be using for an easy point? If you couldn't use the y-intercept? 11 or 9. Either one will work. All right. Plug it in, because that's what we always do to find the other part. -4 times 1 squared. What does that give you? Square the 1 first and then multiply. Square the 1 first. It's going to be 1 times -4 is -4. So what's that point? Close, switch it around. 1, -4. X comes first. So 1, 2, 3, 4. Yep, that's the point. But you got one more thing to do, because you need 3 points. This is easy. What do? Reflect it. You can reflect, no problem. There's no computation with that. Is it opening down like you said it would? Mm-hmm. Is it skinny? Pretty skinny, yeah. Does it have a y-intercept of 0? It's crossing the y-axis at 0, yep. So it meets everything we said. Tell me what you think.
I think it was very hard.